Hello, this will be a demonstration of Proposition 22 from Book 8 of Euclid's Elements, which says that if three numbers be in continued proportion, and the first number is a square number, then the third number also will be a square number. We're given three numbers, A, B, and C. They will be in continued proportion, so that A is to B, just as B is to C. We're also given that the first number A is a square number. And what we want to prove from this is that the third number, C, is also a square number. Now, A is to B just as B is to C. We were given that, which means between the two numbers A and C, there is one and only one mean proportional, namely the number B. And we know from Proposition 8.20 that if there is one and only one mean proportional between two numbers, those two numbers are similar plane numbers. Again, that's Proposition 8.20. That because there is one mean proportional between A and C, the two numbers A and C are similar plane numbers. But we were also given that the number A is a square number. And any number that is similar to a square number also has to be a square. So the number C, being similar to a square number A, itself also has to be square. The number C is a square number. And this is precisely what we set out to prove, which means we're done with the proposition, therefore, etc., QED. This proposition is, for the most part, straightforward, very short as well, only 2 steps. The only kind of weird part of it is that last little bit there, that because A is a square number, C is similar to A, therefore C also has to be a square number. There's a few different ways you can think about that. One of them is to get a geometric intuition for what exactly square numbers look like. So we've gone through a few times before now that they're called square numbers because you can represent them as squares like this. And we call them similar numbers because when we represent them as planes, those planes are similar to each other. But any plane that is similar to a square also has to be a square, just logically. And so the number C being similar to the number A, therefore also has to be a square. So A and C are similar. A is a square, therefore C is also a square. Another way you can think about this is calling back to the definition of similar plane numbers, which is definition 7.21, that similar plane numbers are those whose sides are proportional. Well, the sides of A, they would be equal to each other. I'm just going to call them little a right here, and they're going to be equal to each other. So we have a ratio of A to A, and those are equal. And for C to be similar to A, its sides also have to be equal to each other, like this. So C has to be equal to C for this proportion to work. For A and C to be similar and A to still be a square, the sides of C also have to be equal to each other. But we know any number multiplying itself is a square number, or any plane whose sides are equal is a square number. So because this is true of C, that its sides are equal, it is therefore a square number. Those are 2 ways you can figure out that last step, but besides that, this is a straightforward proposition. So that's all I've got to say about this one, so I'll end the video here and move on to Proposition 8.23.